Topic 11 introduces the idea of an operation that is the reverse process to differentiation. Integration asks us a question: what should we differentiate in order to obtain the function that's in front of us? Now, lots of the integration that you need to do, you can actually just do by looking up a table, but it is important that we regard integration as anti-differentiation, if you like. It's the opposite operation to differentiation. Right, suppose we're looking at y equals x squared, and we've differentiated it. So we've now got this thing, 2x. Let's go backwards. What function did we have that differentiates to 2x? Okay, thinking it through, we can see that it must be y equals x squared. But it also might have been y equals x squared plus 2. Because when we differentiated that, the first term becomes 2x and the 2 disappears. So that's a bit weird. It might also have been that y could have been 2x squared plus 16. Because if we differentiate that, we get 2x. That's a bit of a problem. It could be any number on the right-hand side, any number at all, positive or negative. Could be a fraction, could be a decimal. What we can do, the best we can do, is to say, well, okay, what differentiates to 2x is going to be x squared plus some number that we don't actually know. So the best we can do is to say that what differentiates to 2x is x squared plus c, and we call c the constant of integration. What we're actually doing is integrating. So integrating asks us the question, what function differentiates to 2x? And that process of finding the answer to that question is called integration. The notation that we use to talk about this idea of integration is this long, skinny sort of S symbol. That's the integral sign, and it's an instruction. And we also need it in conjunction with dx, because the dx tells us which variable we're going to integrate with respect to. It's talking about which variable is involved. So this is the integration sign. Then 2x is what we're going to integrate. That's called the integrand, if you need to know. And c, as I said, was the constant of integration. If there are no numbers at the top or the bottom of the integral sign, then we talk of indefinite. Okay, find the function that differentiates to x to the power of 7. So what we're doing is we're finding the integral of x to the power of 7. And the answer would be x, would be x to the power of 8 over 8 plus c. Let's look at the function that differentiates to x to the power of 9. That must be x to the power of 10 over 10 plus c. Now that looks like there's a pretty good pattern, and there is indeed a pattern. The integral of x to the power of n with respect to x is x to the power of n plus 1 over n plus 1 plus c. Now the question is, why can't we have n as being equal to -1? Well, the reason is that if n is equal to -1, then it means our fraction is undefined. So if n is -1, then we're going to use a table. So mostly we use this general rule. If it's not the general rule, then we're going to use a table, and you will be given a table in your exam. And sometimes we can just take a guess and fiddle with our guess to get it right.